Hello everyone, welcome to lesson 7-3, adding linear expressions. As you can see, we're going to continue our chapter of algebraic expressions, but specifically working with adding linear expressions and finding perimeter by adding linear expressions. What is a linear expression? Well, a linear expression is an algebraic expression in which the variable is raised to the first power. You can use models to add linear expressions. Here's a model using algebraic blocks, where we have, for example, add, use models if needed, right? Here, these are the models. So we have 3x plus 4 plus 2x plus 1. Again, you know only the terms, like terms, can be added or subtracted together, where we have 3x and 2x, they're both to the power of 1. So they are like terms. And then we have a constant, which is 4, and a constant, which is 1. And those two will be added together. So 3x's plus 4 singles plus 2x's plus 1 single. When we put all the singles together, we have 5 of them. When we put all our x's together, we also have 5 of them. So we get 5x plus 5. Okay? We can also do it subtraction, and this is using the vertical method, where you arrange them into columns and you place them on top of one another. So we have negative 4x plus 2 plus negative 2x plus 2. So we're adding, and we're just adding negatives. Okay, adding negatives makes a bigger negative, which essentially makes a lower number, right? Negative 4 plus negative 2 is going to give me negative 6x. 2 plus 2 is 4. And there you have it, negative 6x plus 4. This is the method I like to use most, just placing them vertically, one on top of the other with the computation, and we work in columns. Okay, so those are two examples. Here is 1a and 1b. Pause the video and try them on your own. Pause now. Okay, I hope you paused the video. Let's try 1a, where I'm going to use the vertical method, where I have x minus 3, and I am adding them. So I will add x minus 4. We work vertically, and I have an x plus another x is going to give me 2 x's. And negative 3 plus negative 4 is going to give me negative 7. There we have it. Now let's try 1b. So for 1b, again, I'm going to place them vertically, one on top of the other. I have negative x, plus 1, plus, again, focus on our computation, negative 3x. And you can see that I'm not adding anything to R1, right? Right there, nothing's going under R1. So, let's see what we have here. We have negative x plus negative 3x's. It's going to give me a bigger negative. I have negative 4x plus 1. Because our plus 1 has nothing to add with, so it's essentially it's 1 plus nothing. It's just simply 1. I hope that made sense to you, and I hope you got them correct. For example 2, we are going to work with using or modeling the expressions with algebraic tiles. Now, I'm not a big fan of the tiles. I do appreciate the visual they provide, but they are not a very efficient way of completing these questions. So continue to use the vertical style that we did, where we place one on top of the other, and then we work into columns straight down. But let's, because I find that's more effective, but let's use the tiles right now and visualize them, use it for what they have to offer. So we have 3x plus 2 plus negative x plus 4. 3x's, there's our 3x's, plus 2, you see 1, 2, plus a negative x. We have a negative x, and it's being colored in red because it's being taken away, right? Plus 4. Okay, So we can take these 2 and these 4, put them together, and we get 6. This negative x is going to come in here, and it's going to take away this tile. So that means I'm only left with these 2 tiles. So it should be 2 x's, right? And 6. So 2x plus 6. And that's what it is right there. You see? You can go ahead and pause the video and read through this on your own, or just take my word for it. Okay, we've got 2a and 2b to try. Pause the video now and go ahead and try these on your own. Pause now. I hope you paused the video. Let's try 2a, or let's check 2a. We have negative 2x plus 4 plus, as you can see there, 8x minus 4. Okay, I think you noticed right away that the 4's are simply going to cancel each other out, right? Because you have a positive 4 and a negative 4, and that's simply going to be 0, but we don't have to write a 0 in our answer. They just simply cancel each other out. And now I have negative 2x plus 8. It's going to bring me all the way up to 6x. And that's our answer. Let's check 2b. I have negative 4x minus 1 plus 5x minus 3. Because there's my plus sign, right? So negative 4x plus 5 is going to give me 1x. Right? Negative 4 plus 5 brings me all the way up to 1, above 0. So we don't have to write 1x. We simply just write x. Or, as you can see, it's only 1x. And then I have negative 1 plus negative 3 going to give me negative 4. Okay? I hope this is making sense to you. It's essentially just working with adding and subtracting integers. Now let's apply this knowledge to geometry by finding the lengths or the perimeter of certain shapes. Here we have a rectangle, and you can see this rectangle has 1.62x on this length, which means this length here is the same. And on this side we have x, and on this side we have x, so we have 2 x's, correct? So we have 1x plus another x is 2x, 1.62x plus 1.62x. Let's see. Now, we don't have to add them. We can simply just multiply each one by 2, right? Because we know that there are 2 of this value, and we know there are 2 of this value. And we just simply add the 2 together. The length of the sides of a golden rectangles are in the ratio 1 to 1.62. That makes sense. So the length of the golden rectangle is approximately 1.62 times greater than its width. That makes sense, right? Because here we only have an x, but this one's an x times 1.62. It's that much greater. Write and simplify a linear expression for the perimeter of the golden rectangle. So what's the perimeter? Perimeter is equal to 2 lengths, 1, 2, and 2 widths, 1, 2. Okay? So 2 times 1.62x equals 3.24x plus 2x. Or, when we put it all together, 3.24 plus 2 equals 5.24x. Okay? The formula is P perimeter equals 5.24x, where x is the measure of the width. And then if we were given the measure of the width, we just substitute it in, and we get our entire perimeter. Right? So the perimeter of the golden rectangle is 43.492 centimeters. Now that we have seen that, let's try 3a and b. 3a, a rectangle has sides length of 5x minus 1 units and 2x plus 1 units. Let's draw that rectangle now. Forgive me, I do not have a ruler, so I'm going to just do what I can. And we have 5x minus 1 here, and I have 2x plus 1 here, right? Those are my sides. And I know that this side is going to match this side, and this side will match this side. So I essentially have two of these, and I have two of these, correct? Okay, so now write and simplify a linear expression for the perimeter of the rectangle. Okay, so it would look like this. Perimeter equals 2 times 5x minus 1, as I've pointed out here, plus 2, so times 2x plus 1. I can barely fit it in there, sorry. But you can see what I'm writing. And then that is, write a simplified linear expression for the perimeter. That's it. That's A. So we've done what they asked us to do. So I will write this off as this is 3A. Now for 3B, what do they want us to do? Find the perimeter of the rectangle if the value of x is 5.4 units. Okay, so what should we do here? Let's use distributive property, then add all our like terms, and then replace, at the very end, replace the x. So let's do that. Distributive property here first. So I have 2 times 5x equals 10x, and then 2 times negative 1 is negative 2, plus this plus sign right here. 2 times 2x equals 4x, and 2 times 1 equals 2, so plus 2. Now, you probably already picked up on this, but this negative 2 and this positive 2 are going to cancel each other out. So I'm left with 10x plus 4x, which equals 14x. Now let's replace that variable. That equals 14 times, they told us right here, x is 5.4. Therefore, our perimeter is equal to 75.6 units, right? And that is our perimeter, okay? I hope that made sense to you. And that's actually it for today's video. So see you next class, everyone.